A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Indicating uncertainty. In order to understand that in measurement how to indicate uncertainty, following example may help. Let the length of a block is measured with a meter rod and is found to be 22.5 centimeter. As the least count of the meter rod is 0.1 centimeter, therefore total uncertainty in the measured value will be plus minus 0.1 centimeter. That is, plus minus 0.05 centimeter uncertainty develops at one end and plus minus 0.05 centimeter uncertainty develops at other end. In total, the magnitude of uncertainty will be equal to plus minus 0.1 centimeter. Thus, if one end coincides with 10.5 centimeter mark and the other end coincides with 33.0 centimeter mark, then its length along with uncertainty is given by 33.0 plus minus 0.05 centimeter minus 10.5 plus minus 0.05 centimeter. It is equal to 22.5 plus minus 0.1 centimeter. It means that the length of the block is between 22.4 centimeter and 22.6 centimeter. To understand that in a measured value how to find precision and accuracy, consider the final result in equation 3, that is 22.5 plus minus 0.1 centimeter. In this measurement, the magnitude of uncertainty is equal to plus minus 0.1 centimeter. As precision is also guessed from uncertainty in a measurement, therefore the precision is equal to plus minus 0.1 centimeter. The magnitude of relative or fractional error will be equal to plus minus 0.1 divided by 22.5, which is equal to plus minus 0.004. The accuracy in the measurement will be equal to the magnitude of fractional error, which is equal to plus minus 0.1 divided by 22.5, which is equal to plus minus 0.004. Smaller the magnitude of relative or fractional error, greater will be the accuracy in the measurement. Percentage uncertainty will be equal to fractional error into 100%. Now the rule for addition and subtraction of uncertainties. This can be explained with the help of example 1.3. Let x be the final result obtained due to the addition or subtraction of y and z. If x is equal to y plus z or x is equal to y minus z, then delta x is equal to plus minus delta y plus delta z. Now come to the example. If d1 plus minus delta d1 is equal to 24 plus minus 0.1 centimeter, represents the internal diameter of a metal ring, and d2 plus minus delta d2 is equal to 30.0 plus minus 0.1 centimeter, represents the external diameter of a metal ring, then find the thickness of the ring along with uncertainty in it. Now the solution is, let T and delta T represents the thickness and uncertainty in thickness. To find thickness, we know that thickness T is equal to d2 minus d1 divided by 2, which is equal to 30.0 minus 24.0 divided by 2, which is equal to 3 centimeter. While the uncertainty in the thickness delta T is equal to plus minus delta d1 plus delta d2, which is equal to plus minus 0.2 centimeter. Product and quotient rule. This can be explained with the help of example 1.4. If x is equal to yz or x is equal to y upon z, then percentage uncertainty in x will be equal to the sum of percentage uncertainties of the given quantities, that is, percentage uncertainty in x is equal to plus minus bracket percentage uncertainty in y plus percentage uncertainty in z. Now come to the example. Find the percentage uncertainty in the resistance R of a wire given that voltage V is equal to 7.3 volts and uncertainty in voltage, that is the least count of the voltmeter, is equal to plus minus 0.1 volt, and the value of current is equal to 2.73 amperes, while the least count of the ammeter is plus minus 0.05 amperes. Now according to the Ohm's law, V is equal to IR, or R is equal to V over I. Therefore R is equal to 7.3 divided by 2.73, or R is equal to 2.7 ohms. The percentage uncertainty in voltage V will be equal to delta V over V into 100%, which is equal to 0.1 over 7.3 into 100%. The percentage uncertainty in voltage V is equal to 1.37%, or equal to 1%. And the percentage uncertainty in current I will be equal to delta I over I into 100%, which is equal to 0.05 divided by 2.73 into 100%, which is equal to 1.83%, and finally we can write it as 2%. Thus the total uncertainty in the resistance R will be equal to 1% plus 2%, which is equal to 3%. Now the percentage uncertainty in resistance R will be the sum of percentage uncertainty in voltage and the percentage uncertainty in current. By putting the values, we get it equal to plus minus 3%, which is equal to delta R over 2.7 multiplied by 100%. By solving, we get delta R is equal to plus minus 0.081, or uncertainty in resistance will be equal to plus minus 0.081 ohms. Now for power factor, multiply the percentage uncertainty by that power. For example, in calculation of volume of a sphere using V is equal to 4 by 3 pi r cube, percentage uncertainty in volume V is equal to 3 multiplied by the percentage of uncertainty in radius r. As uncertainty is multiplied by power factor, it increases the precision demand of measurement. If the radius of the small sphere is measured as 2.25 cm by a vernier calipers with least count 0.01 cm, then the radius r is recorded as 2.25 plus minus 0.01 cm. Absolute uncertainty is equal to least count, which is equal to plus minus 0.01 cm. Now percentage uncertainty in R will be 0.01 cm divided by 2.25 cm multiplied by and divided by 100, which is equal to 0.4 cm. Now the total percentage uncertainty in volume V is equal to 3 into 0.4, which is equal to 1.2%. Thus volume V is equal to 4 by 3 pi r cube. By putting the values of pi and radius r, we get the volume equal to 47.689 centimeter cube with 1.2% uncertainty. Thus the result should be recorded as V is equal to 47.7 plus minus 0.6 centimeter cube. Now this plus minus 0.6 is the uncertainty in the final result, which is equal to 1.2% of 47.689. In case of power factor, power will be multiplied with the percentage uncertainty. Students, this is the day 4 assignment for you. You are required to solve it. Thank you. Students, you are required to go through the presentation very carefully and with full concentration. Thank you.